a follow-up comment I think is worth making here about the problem we just did in the previous video, and that is, I don't know if anybody was paying attention, but this problem, the one that we were given here, and let me have it in its unfactored form, there's actually a different way that we could have done this. This is actually one that we can do with substitution. So I think it's worth, just as a little review, I think it's worth just pointing out here that we could have done this with substitution. So what would we do here? We'd say that u is equal to x squared minus 5x plus 6. So this kind of thing doesn't usually happen, but take a look. What's the derivative of x squared minus 5x plus 6? It's 2x minus 5, which is exactly the factor that we have up here. And so, using substitution, we actually could rewrite this as the integral of du over u, which is going to be natural log of u plus c, and of course implicit absolute values there. And let's put together natural log of x squared minus 5x plus 6 plus c. Okay, so we have two different methods. Method of partial fractions gave us natural log of x minus 2 plus natural log of x minus 3 plus c, with absolute values, of course, there. And substitution, the easier method, gave us the natural log of the absolute value of x squared minus 5x plus 6. Now, what's going on here? Should we be concerned that we're getting different answers? Well, as it turns out, these answers are equivalent, and the way to see that they're equivalent is by using log rules. So I think this is a good little. This little video isn't really so much a partial fractions video, but more review thing here. That when we have log of something plus log of something, we can combine those together as log of this times this, x minus 2 times x minus 3. And when you expand out x minus 2 times x minus 3, you get exactly x squared minus 5x plus 6. So sure enough, these two answers are exactly the same. Okay, so that is what I want to, I think that's pretty good for this video. But let's end with a pre-class problem, our first one of this section. Integrate x minus 1 over x squared minus 5x plus 6 dx. And for this one, I'm expecting you to do it with partial fractions. Don't try using substitution here. I think you'll get yourself into trouble. Just do this one with partial fractions.